Okay, hello everyone, and welcome to our croit webinar today. Thank you for being here and investing your time and learning something new about software-defined storage. We prepared a short slide deck and a short agenda before we, in a couple of minutes, will go to our product presentation. Let's see. So first of all, we have some organizational topics that we would like to talk about regarding this webinar. First of all, we are using Zoom, and we are also recording this Zoom session, but in a mostly anonymous way. So we need to talk about how this is going to happen and what are your ways to interact with us. So first of all, this is the Zoom window as it should look like more or less on your desktops or devices wherever you're watching. We have the audio settings in the lower left where you can turn on and off your microphone. This will be turned off from our side, so there's it's just us talking today. We also have the chat functionality. If you click on chat, it either opens as a separate pop-up or as at the side of your Zoom window. And when using the chat functionality, you can decide if you only want to address the panelists, so this is Martin, Alexander, and me, or if you want to address the panelists and attendees. In the second case, you won't be anonymous, so your names will be visible. Be aware that you have to pick the right choice there. We also have the raise hand functionality, and if you use this, if you have a question, please also either use the chat or the Q&A function, that is the other one on the bottom bar. And when you use the Q&A function, you can type a question. Again, here you need to tick the checkbox send anonymously so that your question is sent anonymous. If you want to stay anonymous, and please be aware this is recorded, so we will later publish this on our website. So I don't think that we have any confidential topics because we are streaming that. So it's what we want to talk about, but just to make you aware of how we are going to use this. So this is a Q&A functionality. And of course, at the end, you can leave the Zoom meeting on the top right with the leave button. So that's basically all regarding Zoom. I hope everything works fine for you. And so now, after talking about this organizational part, let's introduce ourselves. Allow me to start as I'm already talking. My name is Andy Mutman. I'm with croit nearly from the beginning on, since mid of 2017, and I'm responsible for marketing and sales. And allow me to hand over to Alexander.
Okay, fine. Also from me, a warm welcome to our hands-on webinar today. My name is Alexander Noé, and I'm responsible for business development and our partner program at croit. For over 20 years, I connect people and companies with storage technology. I hope you enjoyed the session and look forward to your questions. Thank you.
My name is Martin Erges. I'm co-founder and CEO of croit. I came from the data center with a strong background in Linux networks, hardware, and Ceph clusters. Yep.
Okay, thank you very much. So after introducing us, allow me to say a few words regarding croit. We're quite a young company, founded in the beginning of 2017. But we have a bit of background when it comes to Ceph, especially in Martin's data center history, where we already operated Ceph clusters since, I think, 2013, so very early versions. This is when we became Ceph fanboy, so we really think that Ceph is a very good unified scale-out software-defined storage system. And but we also noticed that it's kind of hard to set up or to install, to deploy, and also to manage over time, especially as scale-out storage clusters can grow in size and also complexity. So this sparked the idea to found croit, and our core product has the intention to tackle this issue. So our core product is a deployment and management solution for Ceph clusters. So this is in this graphic, it's the left column here. Besides that, we offer hardware for our customers. We offer consulting. This is planning of clusters, supporting clusters. And we also offer training for croit clusters, of course, but also for native Ceph clusters, where we have a really detailed 4-day training that has a lot of practical exercises in it. So this is what we are and what we do. Besides that, we are a founding member of the Ceph Foundation, also a member of the Linux Foundation, and we usually are regular speakers on Ceph days, a little bit less during the COVID time, but hopefully we will engage there more often in the future. So enough of the self-marketing part regarding croit. Or not totally enough, just to give you an impression where we are. We are quite a young company, but we are quite happy with our growth so far. This is some of the installations that we have in the world. It's not all of them, can't show all here, but as you can see, we are quite distributed. We have no regional focus. Besides maybe Europe and in Europe, Germany, where we come from, but it's not that we target this region especially. We are open to serve customers all around the world. Okay, so that's enough about us. Before we go into our product presentation, we would like to give a very brief overview about Ceph. So I don't know if every participant of this webinar is familiar with Ceph and the terminology. So I want to give a very quick overview so that if we use the terms later in the product presentation, you know what we are talking about. Let's see. So what we have here is a high-level diagram that we stole from the ceph.com website. So this is from the original Ceph documentation, and this gives an impression how Ceph works. The red box at the bottom, labeled Rados, is the core of Ceph. Rados stands for Reliable Autonomous Distributed Object Store, and this is the way how Ceph stores data. Ceph stores data in objects that are spread across disks that are again spread across servers in a storage cluster. And Ceph takes care about the data distribution, the redundancy that can be configured, how many copies you would like to have and where they are and what happens if a disk dies. Ceph takes care about that, and you can define and configure the rules that are valid for this data distribution. So this is how Ceph stores data. Based on that, you can access the data using a library if you need to build own integrations. But also based on this library, Ceph brings the Rados gateway, Rados GW. This is the S3 part of Ceph, where you can talk with an S3 client compatible with Amazon S3 with your Ceph cluster. So you can store data in form of objects and buckets, also speaks Swift. Then we have the RBD, the Rados block device. This is where you can create VM images for virtualization solutions like, I don't know, Proxmox or also VMware, for example. And besides object and block device, Ceph also offers a file system called CephFS, which is a POSIX compatible file system. So this makes Ceph a unified file system because it offers those three types: block, object, and file system. So how does it do that? Let's have a look at the Ceph components. If you have a storage server, a storage node, the first thing you need to build a Ceph cluster is you need to deploy a Mon service. The Mon service is the basic component in a Ceph cluster that knows all the parts of a cluster that belong to the cluster, that are up or out or running or not running, and so on and so forth. So the Mon is the instance that knows the Ceph cluster. And of course, you have your disks in your storage servers and your storage nodes, and each disk again is managed by another Ceph service called OSD, the object storage daemon. So each disk is managed by a small piece of software called OSD that takes care about storing the data, replicating it to other OSDs, and so on and so forth. So this is for all disks that you have in your storage node, and this is of course for all the servers that you have. As you can see here, In this example with 3 servers, I put this mon symbol in each of them because even for this component, you don't want to have a single point of failure, so you need redundancy. And what we usually have in a storage cluster is that we have at least 3 mon services, better 5 for a production cluster, so they can be co-located on some of the storage nodes. If we had more than 5 storage nodes, not all of them would have a mon service deployed on them. So, and with that, what you can see here, 3 servers, 3 mon services, a couple of OSDs. You can already build a Ceph cluster. You can create Rados block devices, so those virtual machine images, and every client that probably every Linux client that has a driver for that can mount those VM images. If, for example, you have something like VMware in your environment, you need to deploy an iSCSI gateway or multiples of that, so that you can make your block devices available to, for example, VMware environments. If you plan to use your Ceph cluster as a file system, you need to deploy an additional service called metadata service, MDS. This is the part of Ceph that knows the metadata of the file system. So all the inodes, the metadata, the directories, and so on and so forth. Then we also have, of course, redundancy. Typical setup is with 1 active and 1 or more standby MDSs. So I put 2 in this diagrams. And CephOS can also be mounted on Linux clients. Linux brings a native driver for that in the kernel. And for other environments, you can also export this CephOS file system via NFS or SMB for the Windows world, for example. So it's possible to deploy further gateway services. And last but not least, if you would like to access your Ceph file system or your Ceph cluster with Amazon S3 protocol, you need to deploy a so-called Rados gateway. That is the component of Ceph that makes storage available in form of buckets and objects to S3 clients. So that are the basic components. And having said that, I would like to hand over to my colleague Martin, who will now give you a presentation of our product. Let me stop sharing.
So, can you see my screen?
Yes.
Perfect. Right. Oh, okay. So what I'm going to show you is how to deploy a Ceph cluster with croit. And every step I do here in the presentation can be found in our documentation on the website. So on software docs, you find the production setup guide. It states requirements for the management nodes, for example. And that's the first thing to start with. In our case, for the presentation, we use Proxmox as a hypervisor. It's something like a VMware ES6i. And we just have a virtual machine there that helps us to spin up the cluster. On that virtual machine or on that management node, we installed a Debian 10, but it can be any Linux operating system that is capable of running Docker. And it must have a good internet connection as well as network access to the Ceph hosts. I skipped the networks configurations and go directly to the installation. So we have a running Linux that we want to use to manage our Ceph cluster. And the things we need to execute are just 2 commands, as shown here. And when I go to the virtual machine, we have a empty Docker running here, and then we copy paste the commands from our website and spawn our software. The first command, so on the Docker create, creates a container with the name croit data, and it's used to store persistent information like the database configuration, something from the management node. So there's no actual Ceph data, but the configuration, IP addresses, and so on. The software itself, I started with the docker run command, where we use the volumes from the predefined data container, and that's all you need to do. So that's just 2 commands. And when we take a look at Docker, we now see one container running, and we can find our data container also created here. That's all we need to do on the shell level. Everything else is done in our web UI. So you go on the machine and log in using admin and accept the end user license agreement. And then we start with the wizard. So the first thing we need to know is where to connect to the Ceph nodes to spin them up using a PXE boot. In our case, it's just this interface. If you have complex networks with multiple interfaces, you need to select the right one. The second step is to configure a DHCP server. The DHCP is used to provide the servers with IP addresses and allow the network boot without installing an operating system on the machine itself. Here you can see that we support different types of setups. So we have the possibility to deploy front-end and back-end networks for separating traffic. We also support IPMI. We can configure different MTU sizes, and there's also support for VLANs and LACP channels and so on. But here in the demo, we just present a small example using a single link. And as you can see, the next step is to start a server using the network stack. In our case, I prepared 3 virtual machines. These virtual machines are free, so there's nothing installed on it. They come with some very small disks meant for OSDs, so data storage, and an even smaller one for a monitor. Please be informed that these drives are too small for production environments, so it's just for demo purpose and due to virtual machines. In your real world, you would have a server containing 10 or 12 drives, each having some terabytes of storage capacity. When we now start these machines, I have a script to do that. We can see how the boot is executed, and directly from the BIOS, we go to the PXE environment, get an IP address and contacting our API system. And at that point, the system directly shows up here in the GUI. So we have the full visibility of all the things of our network environment. So whenever our host tries to reach our API, it will be detected, will be shown, and you have all the information at hand. The system itself then starts an operating system delivered by our management nodes from the Docker container. And as we can see, all the nodes are currently starting. And when the start completes, a hardware detection is initialized so that we know what hardware we got there. So it doesn't matter which hardware you have or what you want to use. We detect the internals of each system and find the right drives. As you have seen, there are red lights on the disks. That either means the disk is defect, or it means that it's not yet finished in detection. So we make sure that everything is okay on disk or on the system itself, so CPU, RAM, and so on. If we detect errors, we will show that here in the UI. In our case, we need to start with the installation of Ceph. So we go ahead with one of the 10 gig drives used for or meant for monitor. And we just click here in the bottom bar on set to mon. And then we execute that step. Our software now formats the hard drive, partitions it, and does everything required to deploy the actual Ceph cluster, so a bootstrap. Every step here is just a basic installation, and the moment the first monitor is running in the cluster, we leave the installation wizard and switch to the regular operating mode. So everything else is just day-to-day operations, adding new servers, configuring disk, and so on. And this is something I can show you as soon as our cluster has deployed the first monitor. It takes a few seconds, should be ready any second. Yep. By the way, we are deploying Ceph Nautilus by default, but you can switch the version and you can migrate from an existing installation or from the new installation to Octopus if you like to. But we still suggest to use Nautilus, it's the better release. So now that our monitor is up and running, we see that we have a very, very small cluster having just one monitor, but we have all the features available. And what we want to continue is our installation. So we go back to the server disks and select the additional services we want to deploy. So the first step is to deploy additional monitors, because we always want to have a redundancy here. For production environments, we suggest to have 5 monitors. For smaller environments, 3 months are also okay. Monitors are the first instance to connect as a client. So the moment you the moment you want to connect to the Ceph cluster using Ceph protocols, you contact the monitor. The monitor then gives the client a map or an overview of the cluster itself, and then the client can calculate where to connect, or which drive holds the data he wants to request or wants to write. Second things we need are OSDs. So I just select the remaining unassigned disks and set them to OSD. And OSD is meant for data storage and can be encrypted. It has some impact on performance. And as it is a virtual environment, we just skip that. But it's just a click away and it will save your data. So full disk encryption. We also support DB-wall and different journal partitioning modes. So you can deploy it to any way, any other manual way that you could think of. But everything you find in our UI is battle-proofed. So you can be sure it will work quite well. As you can see, our software installs the OSDs in parallel, but on the system itself in serial. That's because it performs better for Ceph, so it's more reliable, but it scales. So if you have 20 systems, 50 systems, no problem, just select the drives and set them all at the same time, and it will work right out of the box, as you can see. After initial OSD creation, we have used all our disks, and we can switch to the status dashboard. Now we see 3 monitors, so we have a running quorum, and we have 18 OSDs in our test cluster. That's more or less the basics, and now we need to configure a crush map. The crush map in Ceph is used to configure the data placement. So we have a root bucket. So that's a default bucket. And we need to switch the hosts into the root bucket. Hosts outside the root won't be used, so there's no data placed on it. And what we have here is an add unassigned hosts as well function. So we can just add them all to the crush map by a single click. All these changes are unsaved. So when I want to execute them, I click on save, confirm the changes, and then the data movement will happen. So if I have a petabyte of storage and add new systems, I can execute the step whenever I'm ready, deploying the systems, configuring, testing them, and want to go live with them. So that helps to prevent errors in regular environments. The crash map is feature rich, so you find, for example, all the hard drive informations. The blue bar indicates how much data is stored on the drives. As they are clean or empty, there are nothing on it. And when the hard drive reaches near full, the color will also switch. We can reweight the hard drives if there's a requirement for it, and we see the number of placement groups used on that OSD. So how much the data will be, how many placement groups are involved to store data on these OSDs. Besides that, sometimes you want to deploy your cluster on, for example, 3 data centers. That's also something you can do here. You create here a new bucket. You choose which failure domain you want to use. For example, 3 data center. It could be also room, rack, whatever. And you can build all the dependencies in the 3 architecture. And you select the number of data centers, and then we create the new buckets. And now you can just drag and drop the host into the right data center, and of course make sure the physical host is also located in that data center. Makes sense. Now we have a crash map, currently unsaved, that would instruct Ceph to store 1 copy in each data center. And then when we lose 1 data center, the operation will still continue, so no downtime. And that's quite a nice feature, and it's can do even more. But if you have questions on how to configure or how to manage and what options you have, just feel free to contact us, and we will be glad to help you. I just clear that up as we stick to the very small little one. We now have everything that we need to store data. We have our hosts enabled in the crash map. We have OSDs, we have monitors in a quorum. Now the question that comes at hand is, what's the typical protocols you want to use? In a Ceph, we have a unified storage solution. So we have file storage, block storage, and object storage. And let's start with a simple one. So we go to the pools and create a new pool. A pool is a virtual data store used for different types of protocols. So in our case, we want to use RBD, a Rados block device, and we use the replica. We also support erasure coding, of course, and we configure the number of placement groups for that use case. That's something we also help with. It's required to configure good value depending on how much data you plan to store on that pool, but you can always change it up and down later on. It just have a lot of data movement, so we try to avoid that if possible, but as you can scale, it's something you sometimes cannot avoid. In our case, it's an RBD application, so that's the use case, and when we click on create, we will see a new pool on the disks. This pool can now be used to store, for example, virtual disks using Proxmox or using librd or any other RBD capable software, or we can export it using iSCSI. Let's say you want more than just block storage. Let's say you want to have a CephFS, a POSIX file system. Every service we want to install are configured on the server level. So we go to the server view, select the service we want to use for that service. And if you have like 20 systems, you don't want to install every service on every machine. but it's no problem to do that. And in our case, as we just have 3 nodes, we just install every service on all the nodes. Please note that your hardware needs to be configured accordingly, so it must have enough memory and RAM to support all the services you want to install on it. In our case, we start with the MDS, the metadata service. The metadata service stores the POSIX file system information like user IDs, directory structures, and so on, and handles them to the clients. So that's something you need as a basic requirement. And on top of Cephfs, we can put an NFS or an SMB export. So we translate the Ceph internal file system to some more widely used SMB or NFS protocols. So as you have seen, it's quite simple. We just click on it and our software will do all the things required for it. And the same goes for any other service. So let's say we now have our Cephfs. There's not much going on here. We can create my internal customer or what customer or whatever we like. You can mount that on your Linux systems or any other Cephfs compatible OS. We can select where to store it. So as we just have one pool, we cannot select something else. But you have also namespace support and monitoring. That's for service providers. If you want to resell storage, you sometimes need to have billing information. And with the click here, you get an API endpoint where you can request storage usage information and can integrate in your billing solution. But here we just create a folder, and now we have a folder in our file system, and now we want to export that using, for example, NFS. So we go back to the server, install an NFS service. As pre-selected hosts are directly in the dropdown, and then we create the service. It will create multiple services at once, and we just add a new export from my export, whatever you want to call it, and it's located in the file system my internal customer. So we map the export path to the internal Cephfs part, and you can build whatever file structure you want to have. We support multiple NFS protocols, and the simple way is just to use IP to allow access to the NFS shares, but you can also use anything else that NFS Ganesha is capable of. So integrating it with different authentication mechanisms, there's no problem. Yeah, that's all you need to do to have an Cephfs with an NFS export on top. And now we want to, for example, have the same files exported using SMB. So we just go on the servers, select all our servers again, add the new SMB service. There we need to configure something like an IP address that is used for high availability. You can choose whatever IP you want, it doesn't matter, but it must be something your network supports. So let's say that IP address, it's not a valid one, but again, it must be according to your network. We support Active Directory, so you can join a domain, an existing domain. Then you have all the users and groups available to manage your file permissions. Or in our case, again, we just stick to the simple one. So we create 2 users, an admin and a read-only user that we can use to access the SMB shares. With the click on create, our software again goes ahead and installs an SMB service, configures it, configures CTDB as the high availability solution behind it, and spins up the virtual IP address so that we can have a high available SMB connection for our clients. After a few seconds, the X here is indicating that it's not running. With the OK marker, we see that the service is running and everything is okay. So now we have a running SMB service. And of course, we can go to the SMB service and configure it. So that's our SMB configure. We see we have some hosts in a group, and we can create shares here. And as stated before, we want to, for example, share the same files again. So my SMB share, and it should be my internal customer. So we have the same files exported using CephFS, SMB, and NFS. And as you have seen, quite easy, intuitive, and can be administrated by everyone. Now we see in our dashboard, there's more going on in the cluster. So we have multiple services, multiple ways of connecting our cluster, and now another protocol should be installed. So some internal requirement or customer requests want to have an object store. So we want to install S3. We again go to the server view, click on Add Service, or click on the S3 button, and our software takes care of the installation. And by the way, every installation here has some logging, and we can always go to the tasks and see what is going on in the cluster. We have users, we can connect to an Active Directory or LDAP. We can also support Okta, OAuth login, and you will have a task list who changed or created OLDs or whatever is going on. So an audit log is available, and if that's not detailed enough, and you can always see what's going on behind the scenes, we have a more detailed log available, but using the GUI, it's an audit log on the shell. So there is a lot of internal information available to fulfill every requirement. Yeah, now that we have the services up and running, or should be up and running, we can access the S3 Explorer and create, for example, an S3 user. So here we select whatever test user. We can set, I don't know, my individual name. You can configure quotas per user, per bucket. That's always something we suggest. We had customer cases where, a developer wrote some hacky scripts on the Friday afternoon and executed it, and on Monday the cluster was filled up with very, very small objects. That's not so good. So having quota can help you with your environment. Yeah, what else? Something that is, wait here to continue. After you have a user, you always need the keys. So with these keys, you can access the data. So that's something to consider to send out to the clients. Yeah. What else? We have a maintenance view that's quite interesting. When it comes to scaling data or adding new hosts to the cluster and recovering data and so on, you always keep in mind that recovery requires a lot of performance in your cluster. And if you have a lot of client IOs going on, it can affect the performance of your clients. And for that, we have a simple slider. So you can choose if you want to recover faster or if you want to recover slower and having more for the clients. The same goes for things like the regular used flags. In a Ceph cluster, you sometimes need to set a no out flag that helps you to prevent OSDs from being out of the crash map and therefore no longer storing data. It will lead to data movement. And if you do maintenance on your hardware, for example, it is a good way to just disable or enable the no out, so disabling the removal of an existing server, and therefore prevent data movement. And it's just a click away, so you have everything at hand. It's easy to use, and that way you can make sure everything is running in your cluster. Sometimes you have special configurations. When it comes to very special configurations, we have templates, so you can configure everything of every service we have here. So for example, if you want to set special options for the Samba service, you can just configure the template, and the template itself comes with a scripting language, so you can add multiple variables, and we have, of course, a list of them for every script. So depending on the service, you have quite a variety of options, and you can configure everything the service is capable of doing. So whatever is possible. What else? We have server access. Yeah, that's something we often get requests to. As we have started the servers using network, there is nothing installed on it, and you still have full access to the systems. You can just configure a password here. Same goes for IPMI if you want to use it using our software. And you can, of course, add SSH keys so that you have access to your servers. And besides that, we have integrated some ways to access the cluster itself. So for one thing, there is the way in the server dialog. So you can just go on the server, click on terminal, and then you have a nice and beautiful HTML5 terminal. So you can copy paste here. You can execute commands. You see everything that's going on the system. And of course, you can access the container itself. So our management node in the Ceph admin shell. And this container brings all the functions. And here we have direct access to Ceph commands. So we never take away features from Ceph. So you can do everything you like. And whatever you change in the cluster will be directly visible in our software. So if you don't want to create a pool using our GUI, you can just create it using the command line or any other tool you have at hand. So no problem, nothing taken away. Yeah, maybe something also statistics. Of course, we record a lot of statistics over the time using croit. It's available, so you can install access it using Grafana, for example. We have predefined dashboards. Within the statistics, you find metrics like IOPS, bandwidth, latency, and so on. So everything that you need to know about the current performance. And of course, you can always dig deeper using details of the individual host. And then you see, for example, CPU load and number of processors and so on. So you have everything at hand in a single solution. Sometimes you need to access logs, and you can just click on a service or server and click on logs, and then you have the live log of the ongoing system. So everything at hand in a single solution without the need to configure anything. It just works right out of the box. Yeah, I think that the overview, there are more options, a lot more options. Maybe backup, as I got a health warning here or a task advisor information. We provide a cloud backup for free, so you can just enable it, then a backup will be executed and you can restore it from our cloud service. It's fully encrypted, So it's absolutely important that you save your encryption keys. Otherwise, we are unable to help you in restoring the management node. And of course, you can also use local backups. So if you like to have it on your different nodes or different storage, then you can just execute a curl command or something else and have a local backup unencrypted.
Hey, Martin, sorry to interrupt you, but there's a question regarding what happens if the management node dies. And as you are in the backup section, this is probably a good place to mention that.
Absolutely. When a management node dies, the cluster itself will run as usual, so there's no service impact. You just have no information about the current state. You can, of course, log into the systems using your SSH key and then take a note there. But to restore visibility, you just create a new Docker container, click in the wizard on recover from backup, type in the encryption key and login data, and then the backup will be installed. It takes around 30 seconds. And then the management node is restored and you will gain full visibility again. Besides that, you can always, or a lot of customers use virtual machines to host the service itself. So the management node is often virtual machines. It's important that it has local storage, so not dependent on the Ceph cluster itself. And you need to make sure that this management node is running before you are able to start up physical machines, because otherwise the service won't exist. For advanced requirements, you can also install the management node using high availability, but then you have to maintain a SQL Galera cluster and a Graphite cluster. So that's a lot of pain for recovery that can be done in a few minutes. So we usually don't suggest to use that way.
Yeah, but we support it and we have it described on our website as well. Yeah.
Correct.
Okay. Thank you very much, Martin. I think we could go on for hours, but we've only 10 minutes left, and I think maybe we could transport the idea how easy it can be to deploy and manage storage cluster across multiple servers, and how long did it take? 30 minutes, something like that. I'm looking at my participants list. Are there any questions that you would like to ask, either using the chat or the Q&A question? There's the first question. When a Ceph client has the error below printed on the client game console, what does it mean? So what is it here? We need to be concerned about Ceph update snap trace error -22. Martin, are you familiar with this error?
I'm not sure right out of the box, but we can take a look at it afterwards.
Yeah. Okay.
I have another one. Do I have to use a special backup software or can I use common solutions?
So having a backup is always important, even though Ceph has a lot of internal redundancy and make sure no data is lost. There can still be an administrator deleting all your files. So therefore, having a backup is a heavy requirement. With our software, we provide some ways to implement something like a backup. One thing is, for example, for the CephFS, so file storage, we have a snapshot scheduler. With that scheduler, you can say, yeah, I want to have a snapshot of my data, for example, every day or every hour, whatever. And we can configure the path of the file system we want to snapshot or the individual folder. And when the snapshot is done, there's a hook script. So we have something not yet shown. So it's hook scripts. And it can be hooked on this snapshot. So when the snapshot is ready, you can execute whatever script you have, for example, executing an rsync to sync away all the files in the file system, in the snapshot of the file system. and then you have a backup data somewhere else. So every other storage can be connected that way. Besides that, it's also supported to use snapshots and the same mechanism in, where is it? In RBD. And in RBD, you can snapshot a block device and then sync the differential away to a storage or write it on a tape or whatever you want to do. For object storage, it's much harder. Ceph itself provides some multi-region options, so you can deploy multiple Ceph clusters or croit clusters and then connect them, and then the data will be transferred to the different sites or multi-region, and you can add policies to not delete files on the remote side, for example. So there are ways to do that, but it depends on your requirements, and something is internally, but you can also use external standard tools. Yeah.
Okay, fine. I have another one. Can I use inside the cluster parallel different storage medias, or must they all be the same?
You can use all the storage types at the same time. So having HDDs or SSDs or NVMEs, you can mix them, but always remember, if you mix HDD and NVMe in the same cluster, in the same pool, then it would lead to a bad performance. But if you say, yeah, I have my Ceph as high performance pool and my slow backup pool, then you can mix them without a problem, and then you have a slow but cheap backup or archival or whatever you do, and some high performance NVMe storage in it. So yeah, it's possible.
Okay.
We got another question from the audience. Does creation, deletion of snapshots get locked somewhere for monitoring, or is there a way to generate some kind of notification when a snapshot creation deletion happens?
Sorry.
Shall I repeat the question?
Yeah, please.
Yeah. The question is, does creation and deletion of snapshots get locked somewhere for monitoring, or is there a way to generate some kind of notification when a snapshot creation deletion happens?
From Ceph itself, there's no internal way of doing that. With our snapshot manager, it is reported, and you have you can add a notification to the snapshots using our hook scripts. So we provide a way to do that. But again, if you do it on the command line, avoiding our own solution, then we can track that. But if you stick to the predefined ways, it will be no problem. Yeah.
Okay, another one? Any?
Well, Martin, can you say a few words how update and upgrade works?
Yeah, of course. We have installed Ceph Nautilus here, and from time to time you get different versions, for example, for Ceph and security updates. Security updates are handled in memory and automatically by our management node. Major changes like the Ceph version and so on are in the disk images. So when I go on the images here, I see a list of available images. And when a new one is available or software informs you, and then you just select it, download it, and then execute a rolling reboot. The rolling reboot does not cause impact as every service is installed in high available. So that's something we usually do here. And that way you can upgrade the binary blob for the PXE boot. And if you want to switch from a Ceph version to another version, so for example, going from Nautilus to Octopus, we provide a way in the maintenance view where you can add migrate to Octopus, click the migrate to Octopus button, and then start the migration. So it's just a click away. And yeah, we warn about unstable or not yet production-ready features, and Octopus is now getting better, but before the current release, it was a hell of a mess, let's say that. So we avoid problems on customer installation and stick to Nautilus as long as we can, or as long as there is no requirement for Octopus. But it's just a click away, and when you click on the migrate, our software will take care of the service. I do that, and now our software installs Ceph Octopus, so it doesn't in-memory upgrade of the nodes.
Okay, we have another question. It's probably the last one we managed to answer today. The question is, Martin, at what point do you need to worry about latency? Is it microseconds, milliseconds? When do you start to see diminishing returns?
Every millisecond or every nanosecond counts, depending on your use case. So if you think about HDDs, latency isn't anything to consider at all because they are so slow that we don't care about them. If you have a requirement for high performance storage and want to use Ceph, to be honest, there are sometimes better solutions for just having more performance, but not more reliability, because Ceph deals in a way that it always makes sure your data is secure and scalable. When Ceph is the right solution for the requirement and you can achieve multiple 100,000 IOPS with a small cluster, that's not a problem. Then latency matters. So every nanosecond you can drop will help. So choosing a good NVMe, choosing low latency networking, everything that helps you to reduce latency, like setting a CPU clock frequency and so on, that all counts. So it will help to improve performance. But we help with that as well.
Okay.
Okay, we have one last question. Is there a way to prevent clock skew warnings?
Is there a way to prevent that? Yeah, in our solution, an NTP service is installed by default. So if you take a look here, you will find an NTP. If not, it means that our management node is misconfigured, as it looks like. Where is it? NTP. So here we have a running NTP server. If it's installed on the node itself, then this server needs to be configured so that it can serve NTP time to the clients. Our solution brings an NTP server with it. So you need to disable it. It's also stated in our documentation, management node. I would say here, ensure that no NTP service is running on the management node. So even in our demo, we do it wrongly. This helps as our NTP service is included and all the nodes will sync the time with this service. So you just need to make sure it's configured accordingly. So disabled.
Okay, so it's 1 minute roughly past our intended time we wanted to close today. Thank you very much, everyone, for attending. Thank you, Alex and Martin, for doing this together. And if you have any questions after that, please feel free to contact us. You find us on our website with a contact formula, a phone number. You find us on Telegram or LinkedIn. We're happy to answer your questions. We wish you a nice rest of the day, or at least here in Munich, a nice evening. And yeah, stay tuned. We will have more webinars in the future. Thank you very much.
Enjoy.
Goodbye.
Bye.